Anyhow, these are the different fields, or these are the different uh, entities that use the descriptive statistics. However, for our point of interest is data scientists. So that's the reason. So now we will be jumping into the uh, concept or topic that talks about how data scientists harness descriptive statistics for data analysis and insights. So, data scientists use descriptive statistics as an essential tool in their analytical toolkit to analyze and interpret data. Here are the following are the some ways in which data scientists use descriptive statistics. The first one is just a data exploration. Just data exploration. Data scientists use descriptive statistics to explore and understand the characteristics of a data set. They calculate measures such as mean, median, mode, and standard deviation to summarize the central tendency, variability, and distribution of data. So, descriptive statistics provide an initial overview of the data. So, identify potential outliers or data quality issues and inform further data analysis and modeling. The second one that we have here is data cleaning and pre-processing. Data scientists use descriptive statistics to identify and address data quality issues during the data cleaning and pre-processing stage. Descriptive statistics help them identify missing values, outliers, and other data anomalies that may require cleaning or imputation. Descriptive statistics also inform decisions on how to handle extreme values or data points that deviate significantly from the expected distribution. Then the third one that we do with the descriptive statistics is data profiling and data summary. So, data scientists use descriptive statistics to profile and summarize data in reports or dashboards. So, descriptive statistics provide key summary measures that help the data scientists to communicate the main characteristics of the data to stakeholders or team members. Data profiling and data summary using descriptive statistics help in gaining a comprehensive understanding of the data and its properties. Then we have data visualization. Data scientists use a descriptive statistics to create visualizations such as histograms, box plots, and scatter plots to visually represent the data. Data visualizations provide a graphical representation of the data, making it easier to interpret and communicate data insights to stakeholders. Descriptive statistics provide the foundation for creating meaningful and informative data visualizations. Then, the most important one that every data scientist ponder upon, that's the feature engineering. Data scientists use descriptive statistics to engineer new features or variables from existing data. For example, they may calculate aggregate statistics such as mean, median, or standard deviation for a group of data points or time period to create a new features that capture important information or patterns in the data. Descriptive statistics help data scientists generate meaningful features that can be used as input variables in machine learning models. The last one, but the not but not the least one, that's exploratory data analysis, which is very very important before you want to do anything, any model building or model evaluation or feature engineering. The most important aspect to be done is exploratory data analysis in data science. Okay, so the exploratory data analysis, data scientists are data scientists use descriptive statistics as a crucial step in EDA, where they explore data, identify patterns, relationships, and trends, and generate insights that can guide further analysis or modeling. Descriptive statistics help data scientists understand the distribution and variability of the data, identify potential data issues, and generate hypotheses for further investigation. So, in summary, data scientists use descriptive statistics as a fundamental tool to explore, summarize, and understand data in order to gain insights, address data quality issues, create meaningful features, and communicate findings to stakeholders. So, descriptive statistics form the foundation for further analysis, modeling, and interpretation of data in data science projects.